As we look at question 4, we are again asked for volume of a cross-section perpendicular to the xy plane. This time they tell us we're looking for rectangles with the height half as tall as the base, so that's important. And this time they say we are looking perpendicular to the y-axis. So if I was to try to sketch some three-dimensional rectangles, coming up out of the paper, but perpendicular to the y-axis this time, would be this kind of rectangle where it's half as tall as it is wide. Here would be one of the longer ones. And so we are going to sum up all of these rectangles. Each rectangle will have a base and a height, but we know this height is really equal to the base divided by 2, because they told us the height is half as tall as the base. So the area shape will be a rectangle of base times height, or as we've said, base times base over 2. So it appears from our area statement that the most important dimension here is our base. And our base, just like horizontal integration, will be x on the right minus x on the left. And so just as a reminder, our x on the left came from y equals square root of x, and so x was equal to y squared. And x on the right was 4 minus y all doubled when we solved this equation for x. So that means our base will be x on the right, or 2 times 4 minus y, minus x on the left, y squared. And so that means our area is that base. I'm going to distribute this 2 in, so we'll have 8 minus 2y minus y squared. That's our base, times our base over 2, so it's going to be the same thing, divided by 2. And since volume is always the integral of area times dx or dy, we've got our integral. This time, of course, we'll use dy because the thickness of our rectangle is perpendicular to the y-axis. So the setup of our integral is 0 to 2, because 2 is this upper y value, just what our area statement was. 8 minus 2y minus y squared. Since it shows up twice, I'm just going to square it. 1/2 of that, because of this divide by 2, and that divide by 2. There's your volume